Number 3, a cube and a cylinder have the same volume. If one side length of the cube is 6x and the radius of the cylinder is 2x, find the height of the cylinder. So kind of like I talked about in number 1, if there are two objects, like especially shapes, I like to draw them out. So I know I have a cube and I have a cylinder. Let's see, I know their volumes are the same, so I'm probably going to have to use their volume equations. So volume of a cube, length times width times height. Of a cylinder, the volume of any shape is really the area of the base times the height. So the area of the base, which is a circle, is pi r squared times it by the height. So I'm going to have to use those and set them equal to each other. So one side length of the cube is 6x, and the radius of the cylinder is 2x. Well, if I want volume, length times width times height, well, it's a cube, which means all of those are going to be the same dimension. So already for volume of the cube, I know it's going to be 6x, 6x, 6x. I could write it as 6x cubed and then solve it that way. I'm going to keep it this way just because it's going to make it easier to cancel. Now for the volume of the cylinder, I'm going to plug in pi. My radius was 2x squared times the height. And now I have to find the height, which means I need to divide by pi 2x squared. Well, first, I know 2x squared. This squared is going to apply to both of those terms. So that's going to be 4x squared. X squared really means I have two x's being multiplied, so I'm going to cancel out with 2 of the x's from up here. And now if I have 4, I know 6 and 4 are both divisible by 2, so I'm going to reduce those by 2. I'm left with a 3 and a 2. But now this 2, well, 6 is still divisible by 2, so I get a 3, and that's going to cancel that out entirely. So now on the top I have 6 times 3 times 3, which is 54. I have a lone x, and it's all divided by pi, and that is what my height would be.